All right, good evening, everyone. My name is Dylan Parrish, and I will be presenting to you today about a project that I've been working on all semester for my CIT class. Let's go back to slide 1. So this is for our object-oriented programming class here at BYU, Idaho, and in this class, we have spent all semester long creating a game, working on a lot of code and things like that. So I'm going to talk to you about some of the things that I learned in the class from this semester, as well as show you a little bit of the game. So the first thing I want to talk about is static and non-static variable. A static variable is one that is declared once and doesn't change. So an example of that would be like the player's name. When the variable is created, it's saved and used throughout the entire game. So if Jim played and put in his name, he would be the player throughout the entire game. A non-static variable is one where there can be multiple of them. It's not like the static one where there's only one saved throughout the entire game. It can change. And so an example of that is I have a scene here. And this one I feel like works for the non-static portion because we have multiple of them. I know static scene is one, but we have multiple scenes. And so we have our finish scene, our wizard scene, zombie, goblin, and multiple things like that. So that's what makes it non-static, is that there's multiple of them, even though we're using just one scene throughout, but you can see how that works. And then we have our array list, and enum. An array and enum are similar in the sense that they are both fixed in length. You can't add to and remove from it. The difference between them, though, is that an enum is final. Once it's put in there, it's done. There's nothing else that can change about it. In an array, you can change things. You can't add to or delete from it, but you can change the data within it. So what's interesting, though, is an array, all data needs to be the same. So data types. So if they're integers, they all need to be integers, or all doubles, or all strings. And so if it changes, they all need to be changed from string to double, or I think most common would be from double to string. You need to show that number on a printout. So then we're changing that using a parse double, parse string, whatever it's needed. An array list is different than those in the aspect that it can be added to and removed from. So it's more variable because of that in its length. So here I have an example of an enum. You can see these are all our different scenes. So start, finish, wizard, and those are all going to be there. It's final. That's how they're created. It's not going to change. And then here I have an example. So we have our inventory, which is an array list, or an array, in the sense that it's fixed. We only have, I don't remember how many inventory items, but there's a fixed amount of them. But this for loop is going to go through each item, and it's going to test for the greatest strength. And so what it's going to do is it's going to find the item, get the item name, and find the strength of that item. And then it's going to store, if strength inventory right now is null, then it's going to store whatever inventory item it's on, which is going to be the first one because it's going through a list, as the strongest. But if it's not null, then it's going to say, okay, is the current one greater than the one that's already stored? If so, that new one's going to become it. If not, then it stays where it's at. And so we're just trying to find the strongest item. Then we have our throw, try, and catch runtime errors. And so throughout the semester, what we used were return functions. So we'd return like a 0 or a system out print. Something that would let us know that there's an error, or that it's not working, or that it is working. What's nice about this throw, try, catch error is that it's going to be able to throw up error messages that we want for each thing. And then as it throws it up the hierarchy, and so like the one I'm going to show you is wizard view, or question control to the wizard view. Wizard view is the top of the hierarchy, controls the beginning. And so I'm going to show you how that works with try, catch, and throws. So here we have the question control. We see our throw wizard control exception. And so if, for instance, variable 1, variable 2, and variable 3 are less than 0, or even if they equal 0, we have these two messages to throw up. Or even if the result is not what we want it to be, it's going to throw up an error. And then we have our catches, which are try catch. So here's our numbers, try catch for the result. And so from those, this is right here is the try catch that's going to catch that throw. And so if they entered in zeros and stuff, this is the error message that we'll get. Otherwise, if it works, then this is the result that they'll achieve. Then we have our character versus our byte. Byte file systems is what Java initially started with. The issue with it is that it could only do single bytes, whereas character is Unicode, where it could do more than just 1 byte. The 1 byte system could support Western languages such as English, Spanish, German. However, the 2 byte system can support all languages. So right there we can see a benefit of a character stream. And the greatest benefit is that it can be used to print reports or to text easier. It's just great like that. So let me show you the code, the game, which is quite exciting. And so I want to start with, let's just do a run project. And I'm actually going to show you something that I wrote, map list view, which a lot of the code that I've shown you is something that I wrote throughout that presentation. But so the way map list view works, let's go to the run. So in the game, it's going to ask a name. Again, that's like the static. The name's going to stay the same.